Hey guys, I'm back from the break. So let's see where we were. Okay, we're trying to figure out this control inputs load and incrementer of program counter. So let's see. Reset is taken care of. We're directly providing this reset to the reset control, and it signals whether to restart the current program. Reset is equal to 1 or continue executing the current program. Okay, so if this bit is 0, it will continue executing the next instructions, or else if it is 1, then it will set the program counter to 1 and it will start the execution from that first instruction again. Okay, so reset bit is taken care of. Now let's see for the load and incrementer bit. So first of all, let me check out reset program counter. It was inside, let's see, this is project 2. It must be inside project 3, I guess. Where is it? Sequential logic. Yes, it was inside project 3. So that means it must be inside the chapter 3 slides. Program counters, where is it? 1-bit register, multi-bit register, RAM. Okay, here it is. So this is the logic behind program counter. If reset is set to 1, then we are going to ignore load and incrementer bit, and we're going to load 0 inside the program counter. So that's already being taken care of. Now after that, if this reset bit is 0, that means we have to check the load bit, and if load bit is 1, then we need to set the value of program counter to whatever we are passing it as the input, which is from the A register. And after that, if this bit is 0, load bit is 0, then we are going to continue executing the program if this incrementer bit is 1. And if this bit is also 0, that means we are not going to change the value of program counter, so it will remain as it is, I guess. So let's see. We are getting the input value from E register. Yeah, we have already passed it. Now the logic behind load and incrementer will depend upon this instruction, this C instruction that we will be giving. I'm confused whether what is it? I'm confused whether we should even allow this last case to occur. This last case is basically like, a CPU stuck at just a single instruction. We definitely don't want this case, right? And for that to not happen, we will have to always provide incrementer bit as 1. I hope so. We'll see later. So now let's see if the instruction bits are all 0. I'm just figuring out what this input should be based on this C instruction. But what about when we provide a type instruction? A instruction. In that case, what should be the state of this control instruction, control bits of program counter? Well, we definitely, after loading this instruction value inside register A, I definitely want to increment the instruction to the next instruction, right? So that means this increment value should be 1 anyway. Okay, let's see. So let's suppose if the instruction is of type C, then the state of these two variables or inputs will depend upon this jump bits and also ZR and NG. Wait. So what is going to happen is when we pass this C instruction, when the C instruction is being computed, that is basically a computation instruction. So when it is computed, we will get values, output values inside ZR and NG as well. And if this set, and we will be setting this inputs based on jump bits. Now the jump bits will be like where is it? It was somewhere around here. Yeah, it's here. If jump bits, no, this is for destination. Yeah, these are jump bits. So if jump bits are basically these three values. If all three of the bits are 0, then we don't need to jump. What does that mean? That means we don't need to load the value. We want to just increment the value. Therefore, the load instruction should be 0 in that case. But if jump bits are all 1, in that case we do need to jump, unconditionally jump. That means this load bit should be 1 in that case. And for all of these cases, which are basically the conditional jumps, we will check this output ZR and NG. So if output is greater than 0, what does that mean? If output is greater than 0, but how will we know that the output is greater than 0? When will this bits be set? Let's check the ALU. This is for program counter. Where is the ALU? Yeah, this is. If output is equal to 0, then ZR is equal to 1. Else it is 0. Less than 0, then it is. Okay, I get it. Oh, hey man, how are you? Well, yeah, I'm from India. Last time you came online when I was doing machine learning stuff, right? Yeah, sure. You can ask me anything. Well, to be very, very honest, I'm unemployed right now. I don't make any money. So that's why I'm doing the streams. I'm just trying to figure out what I want to do and building my portfolio so that I can get a how much you are worth. So you want to know how much you are worth or how much I am worth? Finance. You wonder about finance. Okay, you as in you wonder about how much you know about finance. If I recall correctly, you are working in the finance industry, right? As a machine learning engineer or something. Okay, studying algo trading. So, what do you want to know exactly? Because to be very, very honest, I don't even know how much I am worth. No, I don't know. I have no idea what that means. Reversion with Kalman filters. Yeah, actually, I had to reach out the company after finding that bug. Like after finding the bug, I had to report that company. You met someone who got hired for it? Yeah, well, I don't think so. I will be hired for my country's intelligence agency after finding their bug. I'm definitely not gonna be hired by them because in India mostly they require certifications and all that. They don't hire you based on your track record, they hire you based on your credentials. So there's that. There are different exams you have to pass to get into this kind of intelligence agencies of India. So after I found the bug, I just basically reported it to the company, and I didn't get that much amount, but I was paid, and that was just it. And after that, I left the bug bounty hunting. And actually, I did not get the amount that that bug was worth. I got like pennies for that bug. MSF Venom, you mean, right? That's but yeah, I have used burp very extensively. So mostly I've been doing web hacking. That's why burp is like the main tool that we use for web hacking. But I have not tried MSF Venom yet. It was like for exploitation and stuff, right? MSF Venom. Payload and code, yeah. So no, I have not used this kind of metasploit tools. Like I think I have used another metasploit tool name. What is the most popular? POS. What do you mean POS? What is POS, by the way? Square. Point of sale. Do you mean point of sale? Point of sale. Well, I don't know which one is popular. Built to make restaurants better. Toast. No, I have not done binary stuff. Like I am interested in all that, but I have not yet tried. Like I did read this book. What is it called? Hacking the Art of Exploitation. I did read this book. Yeah, MSF Venom. So in this book, they didn't use Ghidra and binary and IDA or any tools. In at least in the beginning, they didn't. And I have not read the whole book. So for in the first few chapters, they basically wrote the C a basic C program and try to do the standard, what is it called, buffer overflows and stuff. And maybe it contains this use of these tools, Gitra and Binary Ninja, the advanced chapters. Let me see. So I have not used these tools, but yeah, I have been using Kali for most of the hacking stuff. So I am aware of all these tools. Browse to market. CI. So I guess last time you were here, you posted some of the links for the hacking stuff, right? I, yeah, hacking the art of exploitation, not the art of hacking. It is this one, hacking the art of exploitation. Let me send you the link. And I think this is like the best book if you want to learn binary exploitation stuff. Well, I don't know about them, but most of the hackers I have come across, most of the popular ones, almost like 70% of them recommended this book, Hacking the Art of Exploitation. And I think it is not that much up to date, but the basic concepts still apply, like what is an overflow basically. And this book also accompanies a CD, an Ubuntu CD, which comes with all the practice exercise and all that. And I tried to do this practice exercises from this book, and when I tried to load this kind of bugs in my local environment, which I use day by day, like this one, Ubuntu, most of the stuff didn't work because the new compilers catch the uh, uh, they don't even compile the explore, what is it called, the C program containing the bugs. They don't even let us compile the stuff. So I had to use the Ubuntu which came with this book. It was the not the updated version. It was from the year when this book was released. But still, most of the stuff started arbitrage for the year. Arbitrage, I have no idea what that means. So let me guess. You means you started studying this means you started studying machine learning in terms of financing, right? Good, good. Yeah, that's for sure, man. Lot of shit to learn. In fact, after completing this course, which I'm doing, this one, building a computer from first principle, I'm planning to start learning the Go language. So it seems that you are learning a lot of things at once. So do you follow a strict schedule, like I'm gonna do this today, I'm gonna do this tomorrow, and something like that? The neural recommenders? No, I don't. I don't know. Oh, what's a neural recommender? Okay, so you mean the recommendation system? So well, yeah, I have not yet implemented a recommendation system, but the course I am going through for machine learning stuff, this fast AI, I did watch a video in Can and auto encoders. Yeah, I am yet to learn this Can and auto encoders thing. So where is it? Collab. So by recommended neural recommenders, you mean this, right? Collaborative filtering. Like in this case, we are trying to create a movie recommendation system based on the user titles and ratings. I have not tried to implement my own version of this, but I have gone through this tutorial. So you are learning this deep learning stuff. So have you created any uh, cool models or something, like any GAN or autoencoders and stuff? So if you have not created any models, how are you going to solidify your understanding? So are you just watching tutorials and that's it? Yeah, well, definitely should do program. Dimensionality reduction, denoising. Well, I guess if you that Steam is not good. Hmm. Well, as you are learning, machine learning stuff, you should start with Python anyway, because you're going to use Python for all of this stuff anyway. Well, I have not really yet learned about LSTM. It is a long short term memory or something, right? And I think it is in fast AI course, but it is inside the, let me see, sigmoid and 10h. So these are basically activation functions, right? Sigmoid and 10h. Damn, you're throwing a lot of stuff at me independently in your recurrent unit. Well, if I uh, from my limited knowledge, if I recall it correctly, recurrent neural networks are a model, right? And 10h is basically an activation function that you use inside neural networks. Dude, it seems that you know a lot of things about deep learning and stuff, but have you actually implemented this kind of models? Well, I don't. Well, DevOps guys do make ton of money, and I think it doesn't matter, that much. Like you're going to get paid anyway if you are good at it. You should figure out what you want to do actually. Yeah, exactly. You have to try implementing models. Not just one, you have to try implementing a lots of models. And I think you should definitely check out this course, Fast AI, because this course will force you into building this kind of models. It just starts with computer vision, but eventually you will be building different models as well. I don't think so. I don't even know what that means, multi-objective optimization. I have like, very, very basic understanding of statistics. I don't know all this, you know, advanced things like multi-objective optimization and stuff. They might come in deep learning as well, but I don't know. Right now, I don't know any of those stuff. Right now, I have only learned, the optimization function which is used in neural network, which is backpropagation. Which is basically calculating the gradients of the loss function and tweaking the weights of the neural network based on that. So that's what I have learned till now. No, I've not heard of Rima. Auto-regressive integrated moving average. Damn man, you are throwing a lot of statistical jargon at me. What the hell is this? Auto-regressive integrated moving average. Statistic and econometrics in particular. Is a generalization and auto-regressive moving average. So in all of the tutorials of deep learning I have come across, I have not come across any of these terms that you are telling me about. So I guess they must be, specific to the financial industry, or maybe not just financial industries, maybe hardcore statistics or something. And maybe they are being used inside deep learning models as well, but none of them mentions in the beginner tutorials. I don't even know what a hedge fund is. Long share, many, and yeah, I don't know any of the stuff mean. I have like almost zero knowledge of financial industry. You know, you sound a lot like a mathematics hardcore number guy, not like a programmer or something. So, what is your background anyway? Did you study mathematics or something in your college? And do I sound like a hardcore math guy? Definitely not. Well, yeah, actually, I have learned mathematics and stuff, but not so much statistic and stuff. Like I know basic stuff like mean, mode, and median and all that stuff, but I've not gone into all this advanced stuff that you are talking about. And I like mathematics. Yeah, so I do like mathematics, but not in terms of, numbers or something. Like I the only, yeah, yeah, it might be. So that's what I'm saying. You don't sound like a programming guy anyway. You sound like a financial guy. And so, yeah, exactly. So, hmm, yeah, exactly. So, as I was saying, I like the application part of mathematics. Like you are using the mathematics, application of mathematics in financial field, but you know, the way I'm learning, I'm trying to learn it in terms of deep learning stuff, like how to apply, you know, the differential stuff, differential like calculus and all that stuff, in terms of how to recognize an image, like what is inside an image and all that. So in that way, I'm learning mathematics. XGBoost. So it is a kind of a random forest, right? XGBoost. XGBoost, I have heard about it. XGBoost. Is it a kind of random forest? XGBoost. Gradient boosting, right? It is. Mm. So, well, I have not used this XGBoost or AdaBoost yet, but I have learned about random forest. I try to implement models using random forest for tabular data. Versus Lime versus ambient. I don't know what that is. Uh, Well, uh, XGBoost in neural networks. Yeah, gradient descent. So this is what we use for training the neural network, gradient descent. So backpropagation involves the gradient descent step. That is how we tweak the weights of these neural networks using gradient descent. Like gradient descent, basically, like first we calculate the losses using the loss function, and we try to minimize it using the gradient descent algorithm. That is how neural networks work. By the way, if you want to learn about gradient descent, that channel, what is it called? 3 Blue 1 Brown has excellent tutorial on about it. Like how gradient descent works and all that, like with insane animation. Like animation is like totally great. By the way, if you want to learn about this this models like uh, random forest and all that, this fast AI, they also have a course about machine learning. I have experience with PyTorch. So yeah, yeah, fast AI course uses fast. So what do you mean? You mean, do you need to have experience with PyTorch if you want to become data scientist or data engineer? Is that what you are trying to ask? Like, do you need experience with PyTorch? Well, mm, PyTorch is basically used for the deep learning models part, like for the traditional models that you are talking about, like gradient boosting and all that. For that, most of the data scientists use scikit-learn, this library. So for data scientist and data engineering role, you will definitely need to have good understanding of this library, scikit-learn. But I don't think they will require you to know PyTorch, because PyTorch is required for deep learning models and stuff. Like if you want to create a convolutional neural network and stuff. Maybe maybe some of the posting might require you to know PyTorch as well, because they might be using the traditional machine learning as well as the deep learning stuff for their company. So they might require you to have experience with PyTorch. By the way, this fast AI course is basically also a library, fast AI library. So just like Keras is for the TensorFlow, like Keras is a wrapper on top of TensorFlow. this fast AI library is a wrapper on top of PyTorch library. It abstracts away most of the stuff. Like it makes it is very easy to create these convolutional models and all that, convolutional neural networks and all that. Excuse me. By the way, I heard about this thing, Google data analyst or something. Data analyst certificate. Yeah, that's what I'm telling you. If you try, uh, just try to just watch the first lecture of this course. It is free. It is freely available on the YouTube. You can watch it on YouTube, or it is also available on this website, and see if you like it or not. Google Data Analytics. Either, to be very honest, I don't like data analytics and stuff that much. Like I, you know, like how we can use this deep learning stuff to create programs which have, the cognitive part, like image recognition and all that. But I don't like this number crunching that much. But that's just me. See, this is what you need to pass this certification. Like, this is the curriculum of this course, and they are using R programming. They are using R language for this course. I think this language is specific to data science, like R for statistical computing. Yeah. So if you are interested in statistical computing, which you are apparently, so then you should check out this language, R. Or else you can just get away with learning, Python, and it will be easier, I guess. Yeah, sure. See you. Sure, man. Alright, so where was I? Okay, so I was saying that if all of the jump bits are 0, in that case this load bit will be 0, and if all of the jump bits are 1, this load bit will be 1. Now for all of these conditional cases, we will check these two bits ZR and NG. If both of these bits are 0, that means the computation is not 0. Wait, if this bit is 0 ZR, that means the output is 0, so it is this case. So if output is 0, if this ZR bit is 1, not 0, if it is 1, that means output is 0. If ZR bit is 1 and these 3 bits are 0 1 0, that means this condition is satisfied, and in that case we have to toggle this load bit to 1 because the condition is satisfied. But if this input bits are 0 1 0 and ZR bit is not 1, that means the condition is not satisfied, and it is not satisfied, then we will basically increment the program counter, and in that case we want load we want toggle this load bit, right? And so on for all of these cases. So as I was saying, this 2 bits will take care of all of these cases. So let's check other conditional case. For, let's see, for output greater than 0. So how will we figure out if the output is greater than 0? Well, let's see. If this ZR bit is 0, that means the output is not 0, right? And if this negative bit is also 0, that means the output is not negative as well. So if both of these bits are 0, that means the output is neither 0 nor negative. So that leaves us only one case, that means the output is greater than 0. That means this condition is satisfied. So that's how we can check if the output is greater than 0, and we saw it for this case. Now let's see it for greater than 0, greater than or equal to 0. So if the output ZR bit is 0 and NG bit is 0, then we know that the output is greater than 0. And if ZR bit is 1 and NG bit is 0, then also we know that. Yeah, welcome back, man. By the way, where are you from? Are you from United States? Awesome. So are you a student or working full time, or you are a student full time? Yeah, welcome to the club, man. And do you have a degree? Did you go to college or something? Mm, oh, good. Economics. So he studied economics and now he's into web development. And you are into econ. You just not know. Very know. Well, that's the thing about college. Like you don't really learn those kind of things. Like don't really learn what is being used in the industry. And I don't think they teach you algorithmic trading in economics, right? Yeah, exactly. So, so why didn't you go to college? Like, do you not think it is worth it or something? Or you're not sure what you want to pursue in college? You didn't study until your mid 20s. So, you mean you were not interested in learning all this new stuff until you were in mid 20s? Is that it? Even I went to college, like I went to college to study computer engineering. So I went to college for computer engineering, but I didn't stick around that much. Like I didn't graduate. I only did 2 years of my computer engineering and dropped out after that because I thought it was not worth it. You fail. Uh, You failed what? You mean you failed in your college or in high school or something? Actually, I didn't fail, but didn't. Yeah, exactly. So I didn't go to class. So does that mean you also went to computer science? Damn. So you went to computer engineering college. So actually for first 2 years I did study and I followed everything and I passed all the exams and all that. I didn't fail at anything. But in my fifth semester, I thought that it was not worth it. Like on most of the lectures, I found that those were boring or and I did not like them very much. Like I was wondering why am I even learning this stuff. So that's why I stopped going to college and I said I'm gonna study by myself. Like at that time I was interested in web development, but I was not interested in anything else. Like at that time, I was not interested in this stuff even, like what I'm doing right now in this stream. Well, no, I don't have a Discord yet. I think I should get one, right? Wait, I might let me check if I have a Discord account or something. Like I don't have it for this channel. But for now, I don't think I will be going into security stuff. Yeah, I will be learning about neural networks. So yeah, we can study it together. And that's the reason I'm streaming this stuff because it gets pretty lonely when you try to learn it by yourself. So that's why I'm streaming it live so that in one way it keeps me accountable. Yeah, self-driving cars sound cool. I don't know about genomics, but self-driving cars sound cool. Well, I don't know actually, but it's for sure that they are in demand. Like most of the progress that is being most of the progress that is happening in the deep learning industry is in computer vision stuff and mostly in the self-driving car space as well. Yeah, speech translation sounds cool too. For I have not yet started learning speech translation, but I will be starting it soon because this course does contain speech recognition, I guess. Well, let me check it out. Deep learning for callers. Like it does contain NLP, natural language processing stuff. So they are using recurrent neural network. No, I have not tried reinforcement model yet. I want to get into that shop as well. And most of the cool things are happening in that space as well. Reinforcement models and all that. Like most of the robotics models are using this kind of reinforcement model. Well, I don't think they use CNN inside reinforcement. Like they might be using CNNs for, you know, image recognition, like object detection and all that, but I don't think, and I don't know that much about reinforcement learning. I have yet to learn it. But there are this kind of models. There was this thing, neat or something. Not this one. Neuroevolution, yeah. I think this is a kind of a reinforcement model, neuroevolution. That uses a concept of evolution to train a neural network. I saw this cool video where the guy used this neat algorithm to create a bot, to play that game Mario. He used this algorithm to create that kind of bot, which played Mario by itself. It was awesome. I'm gonna turn off my webcam for a second. I need to use my smartphone. Kalman filter. I don't know what those are. Kalman filters. I have not heard about Kalman filters yet. Or lip reading. Oh. for lip reading and time series thing. Okay. So if it is a time series thing, does that mean it is being used in LSTMs or something? So, because I have not yet learned those LSTM models. The system and the variance or uncertainty of the estimate. Okay, yeah, so this must be how LSTM works, right? Kalman filters, it is saying it is something about state at time t and k plus 1 or something. So this must be a thing about LSTMs. I have yet to learn the recurrent neural network. So I guess after this is done, recurrent neural networks, I will be diving into LSTMs. How simple RNN suffer from exploding gradient. So we have to use methods such as LSTM yet. So it seems that LSTM is, advanced kind of RNN, or I don't know. Maybe I'm wrong. Yeah, it is a kind of a RNN. So in the last lecture, I will be learning about it. By the way, I just created a test server on Discord. So if you want to join, you can follow this link. I don't know how servers work. Like I have not used Discord that much, so I don't know how it works. So yeah, whenever you want to talk, you can ping me there. I don't use Discord that much. Like I created this account only because I was following this bug bounty groups. I used to just chat and post my questions on those servers. So, but I guess I will be creating one for this uh, stream channel so that people can basically to build a community, I guess. By the way, why did you drop it out? Like, do you not like computer engineering, or uh, you didn't like the education system? Couldn't study. Well, it's boring anyway. Like, it's boring to study just for the exams. You have to really push yourself to study in that kind of situation. Like, you don't want to learn that stuff, but you push yourself just to pass the exam. So it gets boring very easily. But if you are learning something just for the heck of it, like there's no exam, but you are learning it because you like to implement something. So in that case, it doesn't become boring anymore. And that's the reason actually I dropped out. Like, I like to learn this stuff, but I don't like to learn for just for the exams. You see that in this case, output is less than 0 if ZR is 0 and NG is 0. Well, let's say NG is 1. That means the output is less than 0. So that means this condition is true. But if both of these bits are 1, that means both can't be 1. And what about output not equal to 0? Well, in that case, we only have to check this bit ZR is equal to 0. If it is 0, that means the output is not equal to 0. So yes, all of these cases are being taken care of. Just need to implement it now. Jump J1, J2 and J3. So let's see how we are going to implement this. PC is equal to 0, PC plus plus, PC is equal to A. So yeah, when all of these 3 bits are 0, then we don't need to worry about ZR and NG. And also in this case, when all of the bits are 1, we don't need to worry about these 2 bits. But for all of these cases, we have to check these 2 bits, right? And if all of these 3 bits are 0, then we can pass 0 to load bit. But if all of the bits are 1, then we have to pass 1. So I guess we can try to create a truth table. For program counter. Let me just copy this thing. So, if all of these bits are 0, that means to create 2 columns for load and incrementer. This will be for the load. So if all of the bits of J1, J2 and J3 are 0, that means the load bit should be 0 and the incremental bit should be 1. And if 0, 0, 1, in that case, okay, in that case we have to check ZR and NG. So we can't say anything about load bit yet. But for the last case, the load bit will be 1 and incremental bit 0. But for all of these cases, we will have to check ZR and NG bits, and depending on those bits, we will either toggle this load bit or the incrementer bit. J1, J2, J3, output is greater than 0. Jump. So you said you studied computer engineering. At least you said that you attended the college. So did you study about this stuff? Logic gates and all that? Well, I guess you can. It definitely seems like you are passionate about this stuff. You only need to create a good portfolio, guys, I guess. Have you tried to look at the job posting of quant firms? Like, what do they require? Like, try learning the stuff that those posting requires. When output is less than equal to 0, jump. For all of these conditional jumps, it seems we have to take care of in total 5 bits. For that, the function will be complicated. And for all of these cases, the only thing we need to do is toggle this load bit or the incrementer bit. How can we do that? If reset is equal to 1, program counter is equal to 0. That case is being taken care of. But if load is equal to, yeah, this is the function that we have to implement. The function will be based on the jump bits and ALU control output, as I said, ZR and NG. So it seems there's no way out. We do have to implement this function anyway. Okay, that means we have to write the truth table. Not just this one, the whole truth table. It's going to get messier. Suppose if we create a function just for jump bits. So let's say for ZR and NG, we create a truth table. So it will be 0, 0, 0, 1, 1, 0, 1, 1. ZRNG, and we'll call it control output CO. Neural network math. And they don't even need to know the neural network math, I guess, right? Because they are not using the neural networks to do algorithmic trading and stuff. Because they can get away with just using the traditional machine learning algorithm. I don't know, maybe they are using, like I have heard that people use, you know, reinforcement learning models as well for trading and stuff. I think I saw a video where a guy used reinforcement learning model to create a bot which, you know, trades the stocks for him. Control output. It is 0, 0. Well, yeah. You mean it's all a be lucky and okay to wait, yes. You mean it is all about money, huh? You mean it is all about money, right? But you know what I think, when it comes to self-learning, like if you are trying to learn something by yourself, then money becomes rather like a disadvantage. Like if you are always thinking about money, how to make money, and what kind of roles or what kind of job will get you more money, then you won't be able to focus on your learning, and you will be hopping around. Like personally, that's what has happened to me as well. Like I have been hopping around different careers because I start some I start something I start learning something, and while the excitement is there, I learn it, and when the excitement fades out, like when it becomes boring, then there's no motivation. Like money works as just a boost when you are just starting, but to keep you motivated, money is not a great motivation factor. Like you have to feel passionate about the stuff that you are learning to keep yourself going. So I guess that's where focus on the money, you know, harms you more than it benefits you. And you see, I'm doing this course. I'm trying to build a computer from scratch. Like there's no direct advantage. Like I'm not going to get a six-figure job directly when I complete this course. There's no direct correlation with any job and the stuff this stuff I'm learning. So that's that. Like I'm not focusing on money that much. If if I were to focus on money, I won't be doing this course. Like tell me what's the direct advantage I will be having if I learn this course. Like nobody is hiring for a guy who writes a computer from scratch. So I'm doing this because I like to learn this kind of stuff. Like I like to learn how stuff works, and uh, to learn how stuff works you have to try to build it by yourself. So that's why I'm doing this. I'm not trying to focus on money right now because I wasted a lot of time doing that. ZR and MG is equal to 0. That means output is greater than 0. ZR is 0 and NG is 1. That means the output is less than 0. And if ZR is 1 and NG is 0, that means the output is equal to is equal to 0. And if both of them are 1, that means, well, both of them can't be 1 at the same time, I guess. Where is it? Program counter. Because output can't be 0 and negative at the same time. Yeah, so both of them won't be 1 at the same time anyway. So this case is not possible at all. So we only have three cases: greater than 0, less than 0, and equal to 0. We can use the first case, greater than 0, in this case to check this condition, as well as wait, what is it? What is the truth table of program counter? Where did it go? Yes, this should be greater than equal to, and this should be not equal to. And this should be less than or equal to. So for this first case, output greater than 0, we can check this condition using the first case, greater than 0, as well as this condition, greater than or equal to 0. So for this first case, this it should only output for greater than 0. For second case, this third thing will be the one we'll be worrying about. But for this third case, greater than or equal to 0, either this thing, first case, or the third case will be giving us the true output. So for this third case, we will have to check two different cases. Or maybe not, because for all of these two cases, no. Jump bits and relay control outputs. So there is a way where I can merge all of these 5 bits, these 3 bits and these 2 bits together and create a function, but it is going to be much complicated. That's why I'm hesitating. I'm just trying to figure out a way where we don't have to merge these two things together, so that I can get a simple enough function. And I think there might be a simple enough function. let me try to think it again. First, I check these 3 bits. If these 3 bits are 0, then I directly pass this value to load an incrementer. And if these 3 bits are 1, then again I pass these values to load an incrementer. But if any of the bits contains this values, that means I can't directly pass the output. I have to compute this control bits as well. But computing these control bits will depend on these cases. So it is 0, 0, 1, and if ZR and NG is 0, 0, then I will pass. That means the condition is satisfied, and in that case I will pass 1 inside the load bit and 0 inside the incrementer bit. But if that's not the case, if this condition is not satisfied, then I have to pass 0 inside the load and 1 inside incrementer. By the way, Detax Mango, what do you think is the biggest obstacle in self-learning, like teaching yourself all the things without going to college or something? What do you think is the biggest obstacle? Okay, let me try to be direct. So, why do you think you can't get a job right now? Like, why do you think you are unemployed? Like, do you think you are, you don't know, you don't have the skills for the job, or what is it exactly that makes you think that, you can't get a job right now? Like, you have to learn something more. You have to show that you know stuff and all that. By the way, I'm just assuming that you are trying to get a job. Like, you might not be trying to get a job right now. Maybe that's the reason you don't have a job. So I'm just supposing that you are trying to get a job and something might not be working out. Anyway, what's the case? Yeah. Oh, that's good. So then what's the problem? So are you actively sending your resume or something? I'm a single learning expert who make less than 100K. Mm. So is that it, that you are trying to learn more stuff and so that you can get a high paying job? Is that it? And that's why you are not trying to get a job right now, because you think that the skills that are required for a high paying job. Okay. But you can always start as a junior machine learning engineer or something, and build the skills incrementally. Because for personally, if I talk about myself, uh, I don't have a job because I don't really have the skills. Like, I'm kind of a jack of all trades, but I don't have a particular skill that I can show to show to an employer. Uh, like I can show my portfolio that these are the projects I have worked and so on. And that's basically what I'm trying to build right now. Like, I'm trying to create a portfolio. And another reason is because I have so many interests. Like, I'm dabbling in different things that I have spread myself out. Don't have a particular focus. Yeah, exactly. So after I dropped out, I used to work as a web developer, but I worked on the front end part, but I started hating it, and that's why I'm not actively looking for a front end developer. I used to work in Vue, and because it's been a long time, I think I have forgotten the skills. Like, yeah, I can make a web app right now as well, but mm, I have forgotten some of the things. Uh, I I used Maven stack, but mostly I have been using Vue, this Vue framework, which is a JavaScript framework for front end. but I have projects in this framework, but I don't like front end development anymore. That's why I'm not getting a job. What kind of projects have you built? Okay, so what kind of things do you imagine anyway? To-do list. Okay, a to-do list as in web app of to-do list, like a to-do list app or something. Oh, awesome. But to-do list are so generic because most of the tutorials, beginner tutorials, uh, make you build to-do list. So that's why I don't think it's a good project for the portfolio anyway. Because I think, I mean, can't get a job like saying that I built this to-do list, and that's why give me the job. Like most of the tutorials teach you how to build to-do list in the frameworks that they are teaching. So that's why to-do lists are not that great for portfolio projects. By the way, what about web development? Are you interested in web development? Like you said, your brother works as a web developer. Maybe you can, work with him, like build a portfolio of by yourself and then work in the company he works. Or do you not like web development? Well, yes, actually, web development involves a lot of things. Front end, you have to take care of front end, back end, then database. For me personally, I can build a full stack application. Like I can build from front end to back end to database management and all that. But yeah, it takes me a lot of time because I learn the stuff as I build, because I don't have a grip over a particular language or a framework. Like I have not used a particular language for a long time that I have, you know, everything, most of the basic stuff by heart. So I have to Google a lot of things, and that's why it takes me a lot of time. And so as per this slide, you don't need to take care of the incrementer bit. I just need to toggle this load bit, so that simplifies the stuff. That means I can keep the incrementer bit as 1. Awesome. Indicators for trading. What are indicators? Are those, a particular application in terms of trading or something? Yeah, I think you should try to build the models which are very specific to the financial space, because it's definitely you seem to be interested in the financial space. So matplotlib, yeah. And I really dread this data visualization stuff. This is J1, J1, J2, and J3. J1, J2, J3. J1, J2, J3, and we have ZR and NG. And the load bit. If all of this are 0, that means we don't need to take care of ZR and NG, and load bit will be 0. And if all of the bits are 1, then load bit will be 1 regardless of the ZR and NG bits. But now if J1, J2, J3 are 0, 0, 1, that means it is this case greater than 0. That means if ZR and NG is both are 0, 0, 0, 0, then it should be 1. And for this case, J1, J2 and J3 output is equal to 0. In this case, if ZR is equal to 1 and G is equal to 0, then the load bit should be 1. For 0, 1, 1, output is greater than 0. For this case, either ZR bit and NG bit is 0, 0, or ZR bit is 1 and NG bit is 0. And in both of these cases, load bit should be 1. And for 1, 0, 0, that means output is less than 0. If ZR bit is 0 and NG is 1, then load bit should be 1. For 1, 0, 1, which means output not equal to 0, what that really means is ZR is equal to 0. And NG bit can be anything. It can be 0 or 1. Yeah. Yeah, detects mango. I'm listening. Yeah, of course you told me about a lot of stuff that I don't really know. And it must be because I have kept myself from the statistic field very much away. Like I've been only learning about the stuff that I need, like actually need, while building the models, or else I just skip it. Or maybe because I'm a noob anyway. I have just started learning this stuff. One, 1, 0, that means output less than 0. So output less than 0, that means either less than or equal to, that means either 0 and 1. Then in that case it should be 1 or 1, 0. And so this is the truth table, and this is what we had to build. Basically, we want a function which computes this once for all of these bits. So if I try to create such a function, it will be like this. If I take the first one, this one in consideration, and the function will look like this for the first term, not J1 and not J2 and J3 and not ZR and not G. Damn. it is going to be a bigger function. It will take ages to simplify this function, and this is just for the first term. We have all of these terms to take care of. What if I try to create two functions, one for these three inputs and one for these two inputs, and after that I end the output? Yeah, that might simplify it. So let me try to create one for the ZR and NG bits first. So for the first term it will be not ZR and not NG, or well, it seems to me that not just the basics, you are close to knowing the advanced statistics. By the way, how do you like statistic? Like statistics is the only thing, which I dreaded in maths. Like I never had problem with mathematics, but statistics was just too much. Like it didn't really wrap my mind around statistic stuff. You too? What do you mean? Me too. Like I have basics down of neural networks and stuff, but I don't know advanced stuff. I'm just a noob. ZR and not NG. Or I don't really need this case. I can You say X, because we don't need to care about ng bit in this case when we are checking just for not equal to 0. So we will be having something like not ZR and not NG, or ZR and not NG. The final case will be something like not ZR and NG, and ZR and not NG. Yes, these are the 4 cases for ZR and NG bits. Not ZR and not NG is for, let's say, it is for greater than 0, and ZR and not NG is for equal to 0, and this case is for greater than equal to 0, and this is for less than 0. No, 0 1 is for less than 0, so I need to get that case as well. Or less than 0 is 100 ZR and not NG. Wait, I already have it. I have not ZR, not NG, ZR and not NG, but I don't have not ZR and NG. Since I don't really need it. Yeah, I do need it. 0 and 1, not ZR and NG. So it should be not ZR and NG. So not ZR, it should be not ZR and NG. This is for when output is less than 0. And this last case is for when output is less than or equal to 0, right? What's the case for output not equal to 0? not ZRNNG or ZRN not NG, or output not equal to 0. You only need to check the 0 bit, so it should be not 0, net ZR. So these are all the functions for different cases of conditional jumps. Now we can place this inside individual variables to use it inside this bigger function. So if I choose this one and call it not ZRN not NG, is basically for output greater than 0. So it is for this JGT, so this is for JGT. Now for JEQ, so JEQ was 010, not ZR, this case. And for JGE, which is jump if greater than or equal to 011, it is this space. Now for JLT, less than 0. For less than 0, we have 01, which is this case. And for JNE, which is not equal to 0, we have not ZR. And for JLE, which is less than or equal to 0, we have this final case. So now that we have those inside individual variables, we can use those variables inside this function. For the first one, we have for 001 output greater than 0, so it should be and JGT. Some of the quants, well, what do you mean they don't know machine learning? Like the people that are hired for algorithmic trading, they're supposed to know the machine learning anyway, right? Because that's what they are hired for. They are hired for, maybe there are also people, like I have heard that, some people who don't create these models, but they create the programs that uses this model. Like I heard that C++ engineers are hired for quant roles as well. C++ for quantitative. So I'm guessing these people, C++ who are hired for this kind of roles, they don't need to know the machine learning, but they need to know the programming aspect of it. See, these are the kind of topics that you need to know for this kind of role. Monte Carlo. So I guess the Monte Carlo are the kind of algorithms that are used in finance, I guess, but they are not necessarily machine learning specific, I think, or maybe they are. See, this differential equation models and all that. So these are kind of, at the intersection of purely statistics and purely machine learning. Like they are the combination between those two fields, like this kind of algorithms. You might have learned about a C language a bit as well, right, in your computer engineering. Or not J1 and J2 and not J3 and 10 JEQ. Or not J1 and J2 and J3 and JGE. Or J1 and not J2 and not J3 and 01. 01 is for JLT. Or J1 and not J2 and J3 and J and E. Or J1 and J2 and not J3 and JL. And the final case, J1 and J2 and J3. Okay, this is the function that we have to create. Can we reduce it further? J1, J2. How can I paste a line from another file? Okay. With the CPU dot html. Okay, so we implement this function using the different chips. Damn, it is going to take a lot of time. Isn't there some way I can simplify this further? I need to get the negated output of J1, J2 and J3 as well. Then I have to get the AND operations and the OR operations. Also have to get this JGT and all the intermediate variables. So this J1 is 0 for these three conditionals: greater than 0, equal to 0 and greater than or equal to 0. And if it is 1, then it is either less than 0, not equal to 0, greater than 0, less than or equal to 0. Maybe I can use this pattern to simplify my function. So if this J1 bit is 0, then we are checking that if the output is either positive or equal to 0. And if J1 bit is 1, then we are checking if it is... Yeah, sure, man. I will see you later again. And if you want to work on something together, you can ping me on Discord and we will figure it out later, okay? See you then. Thank you. So I was saying that if this J1 bit is 0, then we are either checking if the output is greater than 0 or equal to 0. And if it is 1, we are checking if it is less than 0, the output can be either less than 0, not equal to 0, or less than or equal to. So yeah, can't say really anything about these cases, but let me figure it out. There has to be a way. There must be a simpler way to write this function. What the heck? In ALU also we had, many inputs to take care of. What did we do in that case? Let me check the implementation of ALU. So it was inside. Is it inside this R4? No, it must be inside the third. Yeah, ALU is over here. So let's check the implementation of ALU and figure out how we optimize this function. Damn, we used a lot of muxes and ands and alls. Here we try to use, where is it? ALU, where is ALU? ALU. So for what did we do for getting x is equal to 0? not of x, increment it. So based on zx and nx, we either get one of these inputs. So even though this truth table consisted of all of these inputs, the function was not that much complex. Why is that the case in this? Because we were computing the intermediate values. First we computed it for x. Then we did it for y, and for x plus y, x and y. We just selected the value. I wonder if I can use the same logic to simplify this function. JQ2, JGT, J equals. What can I do to simplify it further? Well, I think there's no way to simplify it further. At least I can't think of it right now. So you know what we are going to do? We are going to create all this logic as it is. So this is for program counter. So first we'll get the negated jump instructions. So get not first input J1. Wait, we don't have J1. We have instruction J1 is 0, 1, 2. Damn, if this order of bits is incorrect, then I will have a, it will be a hell to refactor all the code. 0, 1 and 2. Instruction and this should be input and output not J1. Let me copy this. 1, 2, 3, 2, 1. There should be not J2, not J3, and 0. Awesome. We have not J1, not J2, and not J3 as well. And we also have J1, J2, and J3 as instruction 2, instruction 1, and instruction 0. Now we need to get these individual terms. So let's get, okay, first we need to get this JGT and all these terms as well. So for that, let's see, where are my notes? Okay. I'm going to copy all this as well. So now we are going to get JGT. So for that we will need, okay, first we need to get the negated ZR and NG as well. So let's get those. Input will be ZR and we'll keep the output inside not ZR. ZR, this should be NG and NG, not NG. Okay, we have got the negated bits. Now we need to pass it to AND gate. So let's get AND gate, and first input will be not ZR. Wait, this should be A, not input. And we will have B as well, and B will be not NG, and this will give us JGT, which is jump if greater than. JGT. So let me copy this because we will be needing more of this. We'll need, yeah, for second this should be ZR and not NG, and this will be JEQ, which is jump if equal to. I think we can further simplify this term, not ZR and not NG, or ZR and not NG. This is basically greater than or equal to 0. Yeah, we can directly write not NG, because if it is not negative, then it is definitely greater than or equal to 0. So for this thing, yeah, for JGE can have we can directly write not NG. So if it is not NG, that means if it is either 0 or greater than 0. Cool. And we don't need to get JGE because we can directly use not NG in that case. And for this case as well, we can reduce it further. It is less than or equal to 0. If any number is less than or equal to 0, then either it is not ZR and NG, or it is ZR and not NG. Wait, if this is the case, if it is 0, not NG, then it is positive. This looks like it is an XOR gate. Let me check the Boolean identities. What the hell happened? Math processing error. Okay. this is basically a XOR gate, right? Function XOR function. When the number of true inputs is odd, so 0 0, then 0, so 1 0 1 1. This won't ever be the case, because there won't be 0 0. ZR and NG won't be 0 at the same time. So if I XOR ZR and NG, wait. Seems I'm getting confused. Yeah, this is definitely XOR gate. So I can use ZR XOR NG. I hope we have XR gate inside the built-in chips. We might not have, so let's check it. XOR, yeah, we do have an XOR gate, hopefully. Okay, so where will be JGE JLT? Let's use JLT. Let's get JLT. For that we will need and the first input will be not ZR, and second input will be NG. Output JLT. For the final, so for JNE we can directly pass not ZR, and therefore for JLE we will be using XOR gate. The first input would be ZR and second input will be NG. Output will call JLE. Cool, we have got this intermediate variables. Now wait, Yeah, I can reduce this to x and we can get rid of this line. Okay, now that we have got this intermediate J jump steps, we need yeah, we can get this terms now. To get those terms, what do we need? We'll need an AND gate. Right, but we will be needing a four-way AND. Do we have a four-way AND? And 16 and 16. We have a 16-bit AND, but we don't seem to have any other AND gates. Did we not implement those? Project 01. Okay, it seems we didn't. Alright, that means we will have to work with two-way AND only. That is going to get messy here. So that means first we will have to pass not J1 for the first term, and B will be not J2. Alright, since there's no way other way to simplify it again, so we'll call this intermediate T1 for the term 1. Term 1.1. We'll also need another AND. For that, the A input will be J3 and B input will be JGT, and output will place it inside T12 for term 1.2, and the final AND will have P1 1. Damn, it is going to be a nightmare to debug this stuff. We have created a lot of complexity. This will be the term 1. And let's keep it clean. Let's call it term 1. And I need to copy it. Term 2. Now for term 2, we will have not J1 and J2. And term 1.1. For term 1.2, we will have not J3 and JEQ. JEQ. Do we even have JEQ? Yeah, we do have it. So the JEQ term, yeah, wait, this should be 2.1 and 2.2. 2.1, 2.2 and term T2. Okay, for term 3, this will be for the term 3. Now for term 3, we will have not J1, which we already have. Not J1 and J2. So we already have not J1 and J2, so we don't need to compute it again. We have it over here. So let's comment this thing, and we need J3. We need J3 and JQ. So get rid of this and JQE. JGE, sorry, it should be JGE. This will be third term. Okay, we have third term. For the fourth term, we will need J1 and not J2. This is for the fourth term. What do we need for fourth term? J1 not J2. And we will need not J3 and JLT. Do we have JLT? Okay, wait, we don't have JGE, which we used over here. Instead of JGE, we should write not NG, because that's basically JGE. not G. Now again for this term, what was the second term of 4? Not J3 and JLT. Not J3 and JLT. This will be 4.2. So now this should be 4 E4. So now we have the fourth term. For fifth term we will need J1 and not J2, which we already have. So I'm gonna copy this. Fifth. And as I already have this term, fifth term, for fifth term, first subterm will be J1 and not J2, which we already have, and J3 and JNE. J3 and JNE. Do we have JNE? No, I don't think so, because JNE is basically not ZR. Oops, not ZR. This will be fifth. So I can use 4.1 over here and 5.2. This will be the fifth term. You see how complex it is getting? That's what I was talking about. Now for the sixth term we need J1 and J2 and not J3 and JLE. I'm gonna copy this. What do we need? We need J1 and J2. I don't think we already have it. Yeah, we don't have it. 6. And what was the third term? Not J3 JLE. Not J3 JLE. Yeah, we do have a JLE. So this should be 6.2. I should uncomment this. And this will be the sixth term. For the final term, we need J1, J2, and J3. So, well. I will be only leading. J1, J2, as we already have it inside 6.1. Don't need it. And I'm gonna get rid of this term as well. So now I can use 6.1 and this should be J3 for the seventh term. Now I have seventh term as well. Now I have, oh damn, now I have to OR all of these terms, and I don't think we have multi-input OR term. Or yeah, we do have OR 8-way. We can use an OR 8-way. Let's check the implementation of OR 8-way. So we have 8 inputs and output. So we can use OR 8-way, right? And how many terms do we have? We have in total 7 terms. So for the 8th term, we will be passing. Yeah, we'll pass 0 for it, so that it doesn't have any effect. Or 8-way. Does it look like? We have an array of 8 bits, so I have to pass the individual bits like this. 0 will be T1, this should be 1, T2. Whoops. I think I'm gonna copy it. We need 0, 1, 2, 3, 4, 5, 6, and 7 terms. Awesome. And after that, we will have an output, and we will place the output inside. Let's see. Yeah, we can directly call it load. This will be for the program counter, so we'll call it PC load. Right, now let's edit this. This should be T7. Wait, we have 0, 1. All right, let's keep it that way. T7 in 7. T6 in 6. T5 in 5. T4 in 4. T3 in 3. T2 in 2. And T1 in 1. Now for T in 0 will pass false. Okay, we have the PC load finally. Okay, so where are we? have basically implemented this function and have got the load bit. Now what do we need to do? Okay, we have this load bit, we can directly pass it over here. And what about the incremental bit then? Yeah. So as per this slide, it is saying that if load bit is not equal to 1, then we need to increment the next instruction. So that means we have to pass 1 inside this if this PC load is 0. So we'll get a negated part, not input PC load. We call the output PC Inc. Yeah, that's better. PC Inc. And we can pass PC Inc. Yeah. Okay, we have got the PC part as well. Well, it seems that we have all the parts implemented. Is there anything remaining? Yeah, we still need to get this right amp. What is right amp? Basically, wait. Right amp, write to memory. Okay, and where should it come from? What control bit should control this write to amp? Write to memory. Okay, that means write to memory, so it must be inside the C instruction. So write to memory is only when we have a destination where we have, where is the destination? Yeah, out of this destination bits. What are the destination bits, man? Yeah, they are over here. And whenever we are writing to the memory we are writing to the memory over here, here, and here. So 1, 2, 3 and 4 times. So in all of these cases, this write to M should be 1, right? Okay, so let's see if there is a pattern for that thing. Yeah, so this D3 bit, apparently whenever it is 1, then we are writing to the memory. So that means we can directly pass this bit D3 to right amp. This D3 bit is it inside 0, 1, 2 and 3, instruction bit 3. We will use AND. Input is, wait, it should be A. Instruction bit 4th, right? 0, 1, 2, 3, no, 3rd. And B will be true. And output, we'll write it to right. Okay, we have right am as well. What is remaining now? Did you take care of this thing? Let's check the implementation from the beginning. So first we got a mux, this mux, and we passed the instruction as first input, and out am, this out am is the second input, and the selector bit is 15th bit. Okay, So if it is 0, then we are writing to the A register. If it is 1, then we are getting this output writing it to the instruction register. Wait, we are getting the output from outm, but do we have to write it to A register in that case? I guess we should write it. So yeah, I forgot about that step. So this is the A register. We are directly passing A reg L. Yeah, I think we took care of it. Yeah, we took care of it. We have already taken care of it. We don't need to worry about it. Okay. So now you got the A register. We have taken care of this load bit of A register. Oh, wait. There's a typo here. A reg. This should be A reg, I guess. And for mux 16, this is the second mux. We are getting A reg 0, A reg O, which is the output from A register. This will be the first input and input M, and the selector bit will come from the 12th. Okay, and we are writing it to mux O2 output 2. And after that, we are getting the D register. Its input comes from the output M, and the load instruction will depend on this fourth bit. We are writing the output to D reg O. Now after that, this is for the program counter. So we don't need to check the program counter because that's the last thing we implemented. So let's assume we have a working program counter. So we got a program counter, we have provided the inputs and the incrementer and the reset. Now let's check the ALU. First input comes from D register, second comes from the mux, and we have ZX, NX, ZY, NY, F, NO, and output, and ZR, and G. After that, what are we doing? We are getting the A register output and passing it inside the address N. Yeah, because we want it inside address N. After that, we are also getting, we're getting right M. So let's try to run this program. I am absolutely positive this is not going to work, but let's run it anyway. That's what I was worried about. Can't connect gate's output pin to part on line 42. So it is giving us error on the first instruction. I wonder how many errors do we have the whole program. It is complaining about this output M. We can't use it as the input. So that means I will have to get inside an intermediate variable, right? So that's why I kept this line of code. And I also need to check where have I used this output variable, output M variable. here, here, and here. I've used it 3 times. So over here I will pass ALUO. Now it should be ALUO as well. Okay, let's see what it complains about now. Again, an internal pin may only be fed once by a parts output pin. Yeah. Oh wait, why have we got this two? First we got JEQ, and yeah, we were going to get JGE, that's why we copied it. But it turns out we don't need it. So that means I need to get rid of this line of code. Okay, let's load it again now. Missing semicolon. Oh great, where am I missing a semicolon? Okay, thanks for pointing out. "109" is saying that output and PC have different bus widths, so we are passing 0 to 13. That means 14th line. Wait, program counter, of course. Wait. This PC variable has 15 bits, and the output of program counter will be 16 bits. So yeah, I'm passing one less parameter. 15 bits, that means I have to pass either 0 to 14. Wait, I'm confused. So we have in total 16 bits inside PC, output PC. So 0 to 15. Yeah, so I should pass 0 to 14 over here. Now let's see again. 114 have different bus widths, output and address. Okay. How much width does it have then? Address M. Where is it? Where is the interface of CPU? Okay, let me check here only. Address M has 15 bits. Yeah, and I have used 16 bits, so I need to what am I passing to address M? Output of A register. I'm gonna pass 0 to 14 bits. J3 has no source pin. 126. There's no 126 line anyway. J3. Yeah, I might have J3. Okay, I know what's the problem. This J3, J2, we don't even have this intermediate variables. What we have is this instruction. So let me create those intermediate variables. And yeah, this should be A. And we need B is equal to true. Cool. Now we have J1, J2, and J3. Awesome. There are no syntactical errors, but I'm definitely sure we will be having a hell lot of logical errors, and it will be, it will be much harder to debug those logical errors. But anyway, let's try to load the test script and see if it works or not. What the hell? It seems to be running just fine. Can't believe it. Don't tell me I got it right on the first try. It can't be possible. No. I have to screen. I have to press the K key. Oh, what the hell? I got it right on the first try. Damn, I can't believe it. This is awesome. Ooh, cool. Alright, we have got a memory chip and a CPU chip. Damn, we have all the parts of our computer done now. All we need to do is assemble all of these parts and get our final computer. Awesome. but I won't be doing it now in this stream. We'll do it in the next stream. So guys, this is it for this stream. I will see you guys in the next stream. Bye bye.